Hey guys, welcome to Digit, and in this video we will be looking at a DC to DC step-up converter. This is based off the XL6009 SOP8 package. That's basically a single voltage regulator with a built-in line and load regulation, so that allows you to get really high voltages without having to invest in expensive equipment. So the circuit, as you can see, is fairly simple. You have the XL6009 package over here. Right next to it is an inductor for filter purposes, and you also have a couple of capacitors on either side for filtering capacitors, and one pot on the top for, I believe, varying the duty ratio of the device. But you don't need to mess around with anything. All you need to do is vary the input voltage on the left hand side, and you should get the output voltage on the right hand side. Now obviously, when you're playing around with voltages, it needs to be within a certain limit, otherwise you will have a little burnout problem on your hand. In this case, this is capable of pulling in, I believe it starts at 3 volts on the input, and it can go all the way to 32 volts, and on the output side you can start getting, let's say, 3 volts, and it goes all the way to 36 volts if I'm not wrong. The only thing is, in case you are pushing power, you need to look at the wattage so that you can figure out whether you need a separate heatsink or not. Let's say for anything over 2 amperes on the input side, that is on 5 volts, you'd be pushing about 10 watts, and in that case you need to attach a heatsink onto this little package. You can either do it on the front side or the back side. I would advise that you plug a heatsink on the top. And similarly, basically, if you're pushing anything over 15 watts, you definitely need a heatsink, but 10 is where we start advising you to put one in, because once the heat goes up, the electrical characteristics of the board changes and you might not get the results. Now these things are quite handy and can be used with a variety of devices. Let's say you had a Raspberry Pi or an Arduino board and you need to power something that requires a lot more voltage. In that case, either you get a separate relay and try to drive your component using the relay, or you stick to something that is super cheap and it's easily extensible, so you can connect this to any of your devices with ease. Everything is already pre-soldered and pre-tinned. Implementing this into your circuit system should not be difficult at all, and you can get a higher voltage easily. Now folks have been using this to charge their rechargeable batteries, something that doesn't come with a standard recharger station. So car batteries and all those things is something you would want to recharge with this, provided you know how to implement a trickle charge system or whatever your car battery uses. In case you are completely unaware about these things, then I would say you should not stick to recharging your batteries at all, and you should speak to a proper mechanic. But if you know what you're doing and you know what kind of recharging mechanism your device uses, then you can implement a simple circuit using this DC to DC converter. Now at the heart of it, you have the XL6009. Now this is quite versatile. It's capable of consuming about 4 amperes if I'm not wrong. The data sheet should say exactly what this is capable of pulling, because this is not a normal XL6009, it's a separate variant. So this in this case happens to be an XL6009 E1. So obviously characteristics change a little when you have these variances, and you should refer to the data sheet to get the exact metrics that this particular package is capable of delivering. Now this is a fairly simple circuit. On the reverse side you have absolutely nothing. It just tells you that these are the input ports with the plus and minus symbols, obviously, and on the right hand side you have the output ports. You have a couple of screw holes in case you want to mount it onto any device or any project, and that's about it for this particular device. Thank you for watching this video.